Hi there, this is your favorite math learning channel, and I have a limit problem for you. So let's see how we can do it. Well, I basically have n terms because it's going from 1 to up to n. So there are n terms and I'm adding them. So it kind of looks like Riemann sum, but it's not that simple. So let's see. So I can just express this sum in terms of the sigma with sigma notation. So this is just limit n means n goes to infinity. So it will be just 2 to the, so this thing just goes by 1, I over n, over, and here I have n plus 1 over 2, so it's just n plus 1 over I, n plus 1 over I, and I goes from 1 to n. And, but for that form, I need something in the form of sum. I goes from either 1 to n or 0 to n minus 1. These are left and right Riemann sums. This is right one from 1 to n, and from 0 to n minus 1 it's left Riemann sum. So I would need fx, f of a plus I delta x times delta x. And delta x is usually like 1 over n. It can be like a bit different, but it's mostly in this form. So I can try to take this denominator into n parentheses, and it will be just 1 plus ni times 1 over n. So now it looks more like that, but here, so if I say this thing is f of a plus I delta x, this is already I delta x, and so my function looks like 2 to the x, but I have extra stuff here, so it's actually not a Riemann sum, and we can just calculate it directly. But what we can do instead, so my only problem is this part. If I can find it such bounds that would converge to same thing, then I would just be done, and it would be just followed by squeeze theorem. And the way I can do this is that, so I already have 1 over n outside, so maybe I can find two things that would just converge to same thing, and they're just gonna be give me this f of a plus I delta x for a Riemann sum. So I will try to find bounds for this thing. So I'm just writing it 2 to the I over n over 1 plus 1 over ni. Okay, cool. So I know that this n and I is just positive. Well, then this thing is just bigger than 1. But 1 over that thing is just less than 1. So this thing is just less than this thing itself, the denominator part, 2 to the I over n. So now again, like I said, so if I put, for example, if I pick 2 to the I over n for this part, let's write it. I is from 1 to n, 2 to the I over n, 1 over n. Now this is a Riemann sum because, so this is my delta x, and I have f of a plus I delta x. Fx is just 2 to the x, fx is just 2 to the x, and a is just 0, b is 1. Well, those are a bit details, but this is a Riemann sum, and I can just find this limit. And now, so what did I find for upper bound is, let's just write it. So this is a right Riemann sum of the function, so this would be just integral, and so my a is just 0 because I don't have anything here. It's not like 1 plus I over n. So a is 0, b is 1. Well, I already made a video like I explained this stuff. This is the easiest part. So this is going to be the integral from 0 to 1, 2 to the x dx. But this is a right Riemann sum, like I said. Maybe we can also find left Riemann sum. And if we are lucky enough, this would be the lower bound. And what is the left Riemann sum for this thing? Is it's just the same thing. I is from, but this time it's going to be from 0 to n minus 1. I still have n partitions, and that thing would be just same, 2 to the I over n times 1 over n. But here I have this sum, this sigma notation, I is from 1 to n, so I don't want to change it. So I can just put here I is equal to I minus 1. And so I'm just shifting the index by 1. So this will go to right. I is from 1 to n. 2 to the I minus 1 over n. 1 over n. So this would be the left Riemann sum. So which means that if I find my lower bound 2 to the I minus 1 over n, then I will be done. And my limit will just be equal to this thing. So this is my goal and this is my motivation. I just didn't want to like, oh, this is less than that, this is less than that, so I have this. So there is a motivation here. I want to find in the end this thing. So let's write it here. Or it's already at the top. Okay, cool. So I want to find some, like I will use some steps and I will see that this is true. So basically my goal is to get 2 to the I minus 1 over n. So I can just write this I in terms of, so I can just say this is, I will just write it here and then I will do it directly there. So I have 2 to the, I need I minus 1. So I can just say plus 1 over n. So this is just my thing. And I can say, so this is just 2 to the I minus 1 over n times 2 to the 1 over n. Okay, cool. So I can just say this is exactly equal to 2 to the I minus 1 over n. Sorry, this is just same fraction, 2 to the I minus 1 over n times 2 to the 1 over n. So I didn't change anything. I just take the part out what I needed. So I have 2 to the 1 over n plus over 1 plus 1 over ni. So now, like I said, I want to find this thing is just bigger than directly this thing. So if I can show that this thing is bigger than 1, is this bigger than 1, then I'm done. So now this is my new goal and we're just getting closer. Okay, keep it up. So now I want to find just lower bound for 2 to the 1 over n, which we can also think it like 2 to the x. Okay, so I know that 2 to the x looks like, so it's just exponential. It just looks like this, 2 to the x. And well, obviously I can find the lower bound for this thing. And so also, if you remember from exponential power, like with e, this is like e to the x, and we know that e to the x is just bigger than 1 plus x. This is true for any x bigger than 0. Here it's enough for us to take it x bigger than 0 because so this, our power is 1 over n and it's obviously positive. So now we will find a similar analogy for 2 to the x. Well, it won't be bigger than 1 plus x for this range, but it will be actually pretty close to that. And the way I can do this is that, so I will assume that 2 to the x is just bigger than 1 plus x times a. And I will say this is true. So I can just pick any a. I don't know, it can be just 0. Well, this would be true, but I can do it better than that. So I can say that x times a, and this is gonna be true for x is bigger than 0. Now my goal is to find such a. So if I do that, well, so I can say that I can just define a function fx, but this is a different f than that. So let's say gx is equal to 2 to the x minus 1 minus xa. And so basically I will take derivative of it. This is normally how we just show this inequalities. This derivative is just 2 to the x ln 2, ln is natural logarithm, and minus a. And basically I want my critical point to be equal to 0. So what this means is that 2 to the x minus 1 minus a, so this g function looks like, for example, like this. I don't know. I want this turning point to be 0. Here it's like negative, but I want the function to be look like this, for example. This like slope 0 point is directly at 0. So which means that this is the critical point. I want my critical point to be at 0. So which means that if I say this is equal to 0, the x that satisfies this equation is critical point. So I want this x to be 0. So which means that I can just put x is equal to 0. So I will have ln 2, 2 to the 0 is just 1, is equal to a. So I found a. This means that if I pick a is equal to ln 2, then this thing will be true when x is bigger than 0. Perfect. This is actually really useful. So also, if we can just think, we could also do this for any power of any exponential stuff. Like if it was like b to the x, we would just get ln b. And if you think, if you put instead of 2, if you put e, then this also satisfies because ln of e is just 1. And so this is like a more generalized version of this. E to the x is bigger than 1 plus x. We can do better than that. So what did we find? We found that 2 to the x is bigger than 1 plus, and this a is just ln 2. So it's just x times ln 2. Cool. And now I need x is 1 over n, so I will just put it there. Is bigger than, so this is true for any x positive, and 1 over n is positive. So this will be just 1 plus ln 2 over n. Cool. So I can just use it here, and I will say instead of 2 to the 1 over n, I will put this thing, so it will be just less. This is bigger than, 2 to the, so this is just same. I want to keep this thing over n, and I find that this thing is just times 1 plus ln 2 over n, 1 plus 1 over ni. So basically now I got rid of this exponential, which is better for me. And like if you remember, our goal was to show that this thing is bigger than this thing. So our goal was to just show that this thing is greater than 1. Now is it? Well, it's actually now pretty simple. If we only show that ln 2 over n is bigger than this 1 over ni, because I have just plus 1 on both sides, so they will just simplify. So if I show that this is true, then this thing will just be bigger than 1 and I will be done. So basically I have n is just positive. I can multiply both sides by n. So, and I can send this I here. Is it true that I, so this is true if and only if, I times ln 2 is bigger than 1? Well, is this true? Not really. So basically if I is equal to 1, ln 2 is less than 1, so this is not true. But if I is 2, so ln 2 is just ln, so 2 to the 2, which is 4, and ln 4 is bigger than e, so this is bigger than 1. So this is actually true if I is bigger or equal than 2. But what we actually needed was when I is just bigger or equal than 1. So now do we give up? No. So okay, let's see how we can use this. So I know that this last inequality holds if I is greater or equal than 2. So this thing is just bigger than 1, but only if this is true. So this is just 2 to the I minus 1 over n. Okay, cool. So now let's see how we can use it. So basically what we found is that 2 to the I over n is bigger than 2 to the I over n over 1 plus 1 over ni, which is bigger than, but this is true if only I is greater or equal than 2, and this is true for I is greater or equal than 1. We can also write it, but okay, let's also write this, doesn't matter. And this is true 2 to the I minus 1 over n. So basically what was my motivation to do this, I wanted to just add all sides from 1 to n, but now I can't really add it from 1 to n, because if I just sum all of this stuff i's from 1 to n, this last one is not gonna hold. But instead I can just add all sides i's from 2 to n. So if I add i's from 2 to n, 2 to the I over n, and I will also just multiply all sides by 1 over n. 1 over n is positive, so it wouldn't change anything. Bigger than I is from 2 to the n, 2 to n, just this thing, 2 to the I over n, 1 plus 1 over ni. This is bigger than. This is indeed bigger than, because I'm starting i's from 2. I's from 2 to n, so there's nothing sketchy here. 2 to the I minus 1. Let me write it a bit better. I minus 1 over n. Yeah, this is better. Times 1 over n. So this is true. And now, but I want all of these sums to be i's from 1. So what can I do is, I'm just writing this exactly. There's no inequality or something, okay? So I will just say this thing is equal to i's from 1 to n, that thing, 2 to the I over n, times 1 over n. But I don't have I is equal to 1 term, so I can just subtract it. Let's write it with parentheses, so that it's not inside of the sum. If I put I is equal to 1, it will be 2 to the 1 over n over n. So this is the one case when I is equal to 1, and these two are just same. And so I can say this is bigger than, and I will just use the same trick for all of them. So this will be just same, 2 to the I over n. Also, I didn't put 1 over n here. There is also, of course, 1 over n. 2 to the I over n. 1 plus 1 over ni. 1 over n. This is I. And so I have this thing, and I don't have when I is equal to 1, so I will just subtract it. If I put I is equal to 1 here, it will be 2 to the 1 over n. And I is 1, so this is just 1 over 1 plus n, and I can multiply it by n, so it will just be n plus 1. And now I can just say bigger than that. So this was the problem part. We did it only for this thing. I is from 1 to n, 2 to the I minus 1 over n. And so times 1 over n, I will just write it here. This is this n minus, so I don't have the when I is equal to 1. If I put I is equal to 1 here, it will be 2 to the 0, which is just 1 over n. I don't have 1 over n here. And now, so I can just now take I as this limits goes to infinity. And also, if you remember here, we said that if I is from 1 to n, 2 to the I minus 1 over n, I can just put I is equal to I plus 1. And this is exactly equal to this thing, which is left Riemann sum for this stuff, this integral. And we also talked about this thing. So both of these left and right sides are just from 0 to 1, 2 to the x dx. So let's just go down, and I know that if I now take limit as n goes to infinity on all sides, what will I have? So this thing will just converge to from 0 to 1, 2 to the x dx. And if I take limit as n goes to infinity here, well, this is 2 to the 1 over n, so this is just going to go to 2 to the 0, which is just 1 over infinity, and this will go to 0. So I will not write it. This is gonna just converge to 0. Okay, this thing will converge to 0. And similarly, this one will just go to 0. Why? Because it's just basically same, and n plus 1. This will also go to 0, and this will also go to 0. All of these terms are just gonna go to 0. And what will I have when I take limits? Also, when you take limits, inequalities become, if it's just greater, if it becomes greater or equal. So this will be my sum. Let's say limit as n goes to infinity. Well, this was my required answer. I is from 1 to n, 2 to the I over n, 1 plus 1 over ni times 1 over n. This is greater or equal than. And so this is just same, we talked about it. So this is from 0 to 1, 2 to the x dx. Well, obviously these two are just same, so our limit will just go to that thing, and this integral is easy. So if you differentiate 2 to the x, you will get 2 to the x times ln2. So if you integrate it, you will get just 2 to the x over ln2. And we have this integral from 1 to 0 to 1. So if I put that, it will be 2 to the x. And if I do this, it will be, sorry, so this is just 2 to the 1. And minus 2 to the 0 is just 1 over ln2, which is just 1 over ln2. And this is our answer. It was a long adventure, but I hope everything is clear.